Right, today we are talking about compound interest. This is the 6.7 notes. So, if you have a bank account or a credit card, you'll need to think about interest. Interest is exponential growth. So, if you have a bank account, you're usually receiving interest, which is a good thing. And if you have a credit card, you are often paying interest, which is not a good thing. But it is part of life, so we have to know about it. If you buy a car, for example, it loses value over time, which is an example of exponential decay. The word for this we call depreciation. So this is just something that we're going to want to look for because when we do word problems, if we see the word depreciation or depreciates, that's the other form of it, depreciates, then we're going to know that this means exponential decay. All right, so that's going to be our key, our clue when we're doing word problems. So we have two formulas. They're essentially the same formula, but our exponential growth has a plus sign right here, and our decay has a minus sign. So this formula, right, if we look at what's happening here, it's a 1 plus our rate. R is rate. We're going to write that rate as a decimal. So if we said something like 5%, we're going to think, well, how would I write 5 cents? That would be 0.05. So we're going to convert any percent we see into a decimal. So in this case, the 1 that's being added to that rate is really representing like 100%. So it's either going to be a little bit more than 100% for growth or a little bit less than 100% for decay. That is raised to the power of t. T is time. Usually we're talking about years, but it could be something else. And then we multiply it by our starting amount, C. So the way that I went through that, right, we add, right, parentheses, then we do our exponent, then we multiply. So we're going to think about PEMDAS. We're really focusing on those first three letters in PEMDAS. So these are going to follow the PEM in PEMDAS, but that's all we're doing. We're plugging in numbers and we are simplifying to find out how much that we end with, right? Y is our ending amount. So once we plug in the numbers, it's just order of operations, PEMDAS, to figure out our ending amount. So our steps here, first step is to decide if we have growth or decay, right? Growth, we would use our plus formula. Decay, we would use the one with the minus. And we choose that formula. And then we're going to set up our variables. This is going to be by reading the word problem and figuring out which pieces of information they give us, right? So we're going to be looking for some sort of starting amount, right? We're looking for a starting amount. We're looking for some sort of rate that we can convert to a decimal and some amount of time, right? Once we have those things, we plug in and solve, and then we're going to interpret, right? So this just means, what is that number? Is it money? Is it people? Is it, or whatever it is? It doesn't matter. We just have to read through the problem and figure out what we're talking about. So let's do our first example here. So here's our example. You deposit $500 in an account that pays 4% interest compounded yearly. What is the balance after 10 years? So we're going to find our important numbers here. We start with $500. We have a 4% interest rate. And we want to find out what happens after 10 years. So if we're depositing our money into a bank account, right, that is interest. So interest is an example of exponential growth. So we're going to use our equation y equals c, parentheses, 1 plus r to the power of t. And these are just on these notes at the top of the page. We just want that one that has the plus in the middle, not the minus, right? Because it's growth. So now we're going to look through and we're going to see which of these variables over here on the side they give us, right? So, and again, we can look back up to see what they mean. But we have that we start with $500. We have our time is 10 years. And we have the rate is 4%, but remember we're going to write that as a decimal. So we're going to write 0.04. And you can see that they gave us 3 of these. We're still missing one, but that's the one that we're going to find. Okay, so what I'm going to do is I'm going to plug these all into my equation. So we don't know what y is, so we're going to keep that as y. C is 500, so we're going to put 500. Then our parentheses, 1 plus 0.04 raised to the power of 10. So as I go through this, there's only so much that I can do without a calculator. I can certainly add 1 plus 0.04. And that's 1.04. But this next part are exponents. So we did our parentheses. Right now we're working on exponents. This part I definitely need a calculator for. So if you don't have a calculator that does exponents, you need to get one. Okay, so after I add 1 plus r, now I can raise 1.04 to the power of 10. So I'm doing this on a calculator, right? So you can check if you can do this on a calculator. You should get a similar number. It's going to have a lot of decimal points, but I'm just going to round it. So we had 2 decimal points. I'm going to keep it as 2 decimal points. So I'm going to do 1.48. The number I got was 1.480244, blah, blah, blah. Okay, we'll just keep 1.48. Okay, our last step then is to multiply. So to multiply, I'm going to keep that number in my calculator and just do times 500. So 1.48 times 500 is 740. So approximately 740. So the last thing that we're going to do here is we're going to say interpret, right? 740 what? Well, if we're talking about the amount of money that we have in our bank account, right? This is a dollar amount. So we're talking about $740. All right, let's move on to the next problem. This next one says John buys a car for $33,000, right? So that's our starting amount, right? How much we bought the car for. His car immediately starts depreciating. Okay, that's one of our keywords here. Losing 25% of its value every year. So if we don't know what depreciating means, it's going to tell us right there. It means it's losing value. How much will the car be worth in 5 years? So we know from our keywords, depreciating and losing value, that this is a decay problem. So it's going to be y equals c times the quantity 1 minus r to the power of t. So now let's fill in. I circled all my important words, but we have to just fill them in to where they go. So our starting value here is $33,000. Our rate is 25%. So think about how you would write 25 cents, 0.25. And then we're talking about 5 years. So think about if you bought a new car for $33,000, how much is it going to be worth 5 years later? Let's find out. Let's think if you have a guess right now. What would it be? Do you have a number? Think about it. All right. So remember, we have 3 steps here. We have the PEM in PEMDAS. So the first thing is our parentheses. 1 minus 0.25. So if you have $1 and you spend a quarter, you now have 75 cents. And now we're going to do 0.75 to the power of 5, right? So again, that's not times 5, it's to the power of 5. We should get a smaller number. So I'm plugging that into my calculator and I get a decimal, and it's 0.23730, blah, blah, blah. All right, so let's do 0.237. Okay, so that was my exponent. And our last step is to multiply. So I'm going to leave that number in my calculator and just click times 33,000. And we get, 7831.054. And the decimal keeps going. But remember, we're talking about money here. So I'm going to leave it as 2 decimal places. Because remember, money goes to 2 decimal places because it's dollars and cents. And that's our answer. $7,800, not a lot. So our car started at $33,000, but 5 years later, it is worth just a fraction of what it was. All right, let's move on to the next one. One more example here. Same idea. So let's just go through this process. We should be pretty good at it by now. We are depositing, or Charlie is depositing, $10,000 in an account 4 years ago. Okay, so if his account pays 6% interest, how much does he have now? So this one's worded differently, right? We're starting 4 years ago. We have 6% interest, and we want to find out how much he has now. So this is still talking about 4 years later, right? So he put $10,000 in a bank account. We know it's going to have interest, so this is going to be an exponential growth problem. So we're going to use our equation with the plus. We started with $10,000. It was 4 years that we were watching this account, and it was 6% interest. So 6% is 0.06. And we're trying to find the ending amount. So let's see how this goes. Y equals $10,000. So that's our starting amount. 1 plus 0.06 to the power of 4. So we can add in the parentheses, right? That was our parentheses. Then we're going to do our exponents. So this is where I'm going to need my calculator. So I'm using my calculator. Take yours out if you have one. 1.06 to the power of 4. So this should give me a slightly bigger number. I get 1.262. All right, so let's do that. 1.262. And then I'm just filling in the rest of my equation. Times 10,000. So I'm just going to leave that in my calculator and do times 10,000. And we're going to get Y equals. Remember, this should always give us a bigger number if it's growth. $12,624.77, right? So I'm rounding that to 2 decimal places because we're talking about money. So remember, we just used the PEM of PEMDAS to simplify these equations.